We're continuing on a tutorial on how to create a custom bathymetry from an image of a chart at a specific offshore location using Rhino, and we're going to use this mesh in a ProteusDS simulation. So a typical chart you might see looks like this image with depth contour lines. Previously, we imported this into Rhino, oriented it so that the north lines up with positive x and east lines up with positive y, so that the mesh we generate will line up to the ProteusDS coordinate frame. It's also to scale. The next step, what we want to do is create some polylines that trace along the depth contours that are indicated in the plot. So first we'll go polyline, and I've got OSnap on with end and near and point just to make this process a little bit easier. So this is the 2 meter depth line. It doesn't have to be super perfect, as long as you get the general kind of shape, the bathymetry. Press enter, and a shortcut is just press enter again, and then it repeats the command, so that helps move things along a little faster. This is the 4 meter depth contour line here. You just do Control Z if OSnap's causing a little bit of trouble there. Okay. And we're going to continue on drawing the depth contours and adjusting the height shortly. So, all right, after I've added and drawn through on the contour lines to get the polylines into Rhino here, the next step is then offsetting them in the Z direction. So you use this using the curve command. So I've clicked on one of the polylines. This is the 10 meter depth contour. So we'll click on that curve, and we use move vertical, V for vertical, point to move vertical from, so we go 0, and we want 10. And if you look on the side views here, you can see that line gets moved up, and I've actually already moved the other lines around here. So we've got our contour lines defined by polylines. The next step is making a polyline that closes around the perimeter of all of these lines, through which will fit the surface, the geometrical surface for the bathymetry. So do one last polyline, and if you got on snap on end, that makes this go pretty quick. Around here, we don't need to connect them, just make sure that everything gets closed off. We can actually go up here like that. Just making sure everything's closed off. Oops, I think I just missed that one there. And that should do it, so we'll press enter. And now we use the patch command. Actually, we can delete this bathymetry picture image now. Oh, you can see I missed a point there. So we'll just add another polyline to close this off here. There. Again, we just need to have a perimeter around everything to make sure the patch works properly. So patch, and it'll say select which surfaces to fit through, pick everything. And I've got my sample point spacing and other parameters here. We can preview it to see what it looks like. That looks generally pretty good. So we'll go OK. And what we want to do is click on the perimeter lines here. So if you hold Shift and then left click, you can select all the way around. We just want to trim off the excess. So we'll go trim, and then we're going to click on the outside part of the geometry surface there. I'll go enter to finish it there. Okay, so now we've got our curves, polyline still, as well as the surface. And just to keep things clean, I'm going to select everything. I'm deselecting the surface. I'm just going to delete all the polylines because we don't need them anymore now that we've got this nice geometry here for the seabed. Now we need to fit a polygon mesh within this geometrical surface. So we just type in mesh and click the surface, press enter, and we can adjust how much detail we want to have in there for the number of polygons. And that's one way to do it. You can make it with triangles. There's also in newer versions of Rhino quad remesh. Makes a slightly different kind of mesh, and you can control the total number of polygons that are used. Maybe that's 2000, maybe a little bit large. We'll just go OK. I think that looks pretty good. So we want to delete the surface. There's our nice quad bathymetry mesh there. That's our polygon mesh. The last thing we need to do is make sure the normals are pointing the right way. Remember, positive normals have to oppose the positive Z direction. So we can highlight the polygon mesh, dir, and oh, it looks like they're already pointing the right way, so that's great. I'm going to save this, and then we want to go export selected. And the OBJ file we're going to call this is bathymetry chart. Go OK. And here's the standard output settings. There's nothing really special here. Just go OK. All right, now the file we should see over here, bathymetry chart. And we'll go bathymetry track diagram. I'm going to add it here. Oops, I'll just delete that one there. So let's check it out and see what it looks like in simulation here. The file name is bathymetry chart.obj. Just run a very quick simulation. Let's see if we can plot the depth colors in PostPDS. All right, so it looks like we've got it in here, and there's some surfaces quite close to the water, so you can see it's coming out of the water. Let's turn off the water, and there's our bathymetry, and we'll go plot depth. And we've got some nice colors there showing the depth contours for this particular site. So it's another way to create a custom bathymetry using chart data with Rhino for ProteusDS. Thanks for watching.